your last few years MCQ. So sometimes they can ask SEO structured SEO also they can ask to write the name, right? Now please tell me first, shall I directly discuss the questions, past paper questions, or you need a little bit of theory like about this? But I think you had done the inorganic chemistry, you had done, right? Completed D block, and I have shared with you D block short notebook also. Can you tell me now how many of you now? Pramod is asking, sir, a little bit of theory. What about the others? Do you need a little bit of theory like D block complexes, IUPAC nomenclature? Or else shall I directly discuss the question? Now I'll share the what's this my D block short notebook also, then I will explain from that, then no need to write much. I don't know how many of you went through this. You can see the screen, right? Okay. The last few pages of this you can see cation and anion. So actually the first one from number IUPAC nomenclature of this. So there are some changes here I have done. Positively charged ligands, negatively charged ligands, how to write the name. So one change now, negatively charged anion, simple anion, negatively charged in complexes. So the name ends in actually is fluoride. You omit the last letter and add O, fluorido. That is one change. Before 2011, so it's just fluoride, tetrafluoro, like tetraido, like that. But now it's iodido, chlorido. So we don't call it tetrabromo or tetracyano. We don't cyanido. So cyanide, we omit E and add O. Bromide, the last letter we omit and add O. Chloride, we make it chlorido. We omit the last letter of this anion, simple anion, and add O. That is one change. So that's very important. And so these are a few examples I have. These are the 4 different types of questions you can get. Can you see the last page of the D block short note? So everyone, how many of you have got a hard copy of this? Please raise the hand. The print this D block short notes hard copy. How many of you have the? Okay, then you can. Okay, except Vinhar, all the others have. Right, good. Now you can see these are the most commonly they can ask. Okay, everyone has got it right. Very good. Now you can see here. Look at the screen. Number 2. Number 1. Positively charged complexes. So then positively charged complexes. The most important thing, you should not leave a gap until you write the oxidation number of the metal ion. So metal ion, the oxidation number you can get from this complex, so from the name, and then you can okay, first I'll tell what information you can get from the name. So one information, you can get the oxidation. Any IUPAC name of this D block complexes, you can get the oxidation number of D block metal, right? Oxidation number of D block, because with the change of the oxidation number, color also changes. Color also changes. Color of the complex changes with the oxidation number. So you can get oxidation number. You can get oxidation number of D block metal or central metal ion, central atom. Then the other info you can find the or else coordination number also you can find, coordination number, how many ligands combine with that, plus you can get number of ligands. So these are some of the informations you can get, and the other one you can get whether is the charge of the complex also you can get an idea, charge of complex. whether it's positively charged complex or neutral one or negatively charged complex, also you can get an idea from that. Okay, so therefore mostly they give the complex, and they will ask you to MCQs also they have given the name out of the 5 answers given, you have to select. But sometimes they can give you the name, and ask you to write the this complex. They will ask you to write the complex from the name to build the complex. Now so I have got here 2 examples for positively charged complexes. You have right. Now here amine, diamine, silver 1 ion. So silver 1 is what? Here the charge is 1, so you can hear the charge is +1. Therefore it's you can directly see the charge, because if the ligand is neutral, then this plus should belongs to silver. So this directly belongs to silver. Therefore this silver 1. And after writing the Roman numbers, so Roman numbers we use for the oxidation number, and we have to put that oxidation number within bracket until the oxidation number no space. After that you have to leave a space and write ion, right? Diamine, silver 1 ion. Now imagine in this complex, if you have more than one ligand, assume you have not only the ammonia, then you have H2 also act as a ligand. If you have more than one ligand, then you have to follow the alphabetical order. But when you consider the alphabetical order, you should not consider this di-tri. So di-tri, that is not, that prefix is not considered. So you have to consider the original name of the ligand. So example, now if you have both water and ammonia, then you go for what? This is also very important. Now this is amine, tetramine, and both is start with A. Then what is the next one? Then you go for the next letter. So if you want, you can copy down those information separately in your short notebook. If there are 2 ligands starting with the same letter, then we go for the second letter. So what comes then A, from A we can't decide what should be written first, then we go for the second letter. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q. M come first, then Q comes second, right? Then you go for what? M. Then amine should be written first. Is that clear? Amine should be written first. Then you get the aqua. So if you have diaqua and diamine, then what? First you have to write diamine. Sometimes imagine tri and di both there. Then di and tri not considered for the alphabetical order. That's very important. Di, tri not considered. Only the name of the ligand is considered. Is that clear? So both these are neutral ligands. Therefore directly the charge. So if you get at the end of the complex, if you get 3+, that 3+ is chromium oxidation number. Here plus means silver oxidation number. Sometimes you can they will give like this also. Instead of writing like this, now you have done the tolerance reagent. Tolerance reagent is diamine silver nitrate. So then they can give this way also. NH3 twice, Ag, then NO3. So there's a plus charge, then it get cancelled by anion, NO3 minus. So then this is diamine. So instead of putting dot 2NH3, they can put within bracket 2NH3. So both are accepted, but mostly in the exam they can give within bracket. If you put within bracket, then no need to put a dot. I think that's a printing mistake here. So the other one they have given just dot. If you put a dot, then you have to put 6NH3 like in the previous one. So here you can omit the dot, because just CrNH3 6, that means hexamine chromium 3 space ion. So there must be a space here. That's very important. Those are the common mistakes we have observed in marking. So the students, they put you have to leave a space here, right? That space is important, but in between no space. In between that no space. Is that clear? Any questions about this positively charged complexes? Anything else that you want to clarify, or you want to, if you have any doubt, you can ask. Okay, you can unmute or you can put to the chat. And if you want, you can write here itself short notebook, last page, D block. You can check with I'll tell you which page in your resource book, Inorganic Chemistry Unit 6 resource book. they have given the D block separated the rules, IUPAC rules, when writing the complexes, the name of the complexes. Page number 169, as I remember, page number 169 in the resource book. Please write in your D block short note the last page, right? Refer page number 169, page number 169, D block resource book, unit 6. Right. You can see here nomenclature of simple, complex ion and compounds. Right. So they have given here name of the anion acting as a ligand in the complex can be obtained by removing what? By removing the last letter of the anion. If it is an anion only, yeah, and adding O, chloride become chloride. Earlier also explained, they have given that in here. And neutral molecules acting as ligands are usually given the name of the molecule. So the name of the molecule is given. So here name of the molecule means H2O aqua, NH3amine. But here they have given only 3 neutral ligands. Okay, but I have given here they have given only 4 anions, but I have given more than that in the D block short note. Here you can see I have given before this there are so many. So I have given a separate table about these ligands. So whatever you get, you can, so that you can manage. Negatively charged ligands, I have given all the possible ones in your syllabus. And there are positively charged ligands also, very rarely. Very rarely you can get positively charged ligands. Then you have to be careful about that. Then these are neutral ligands. Amine, carbonyl, nitrosyl, aqua, thiocyanol. Mostly you get aqua and amine. Most of the complexes you can highlight. Here the most common ones, these two, ammonia and H2O, most of the complexes. And negatively charged ones you can get mostly these stuff. So others very rarely you get. Right? Sulfate also can occur, sometimes sulfate. Right? Then in the other most importantly, when this is if the complex is negatively charged. If it is anionic complex, the metal you can't just write. That's what you're going to. That's what I have given in the D block short notebook, the number 2. Okay, I'll show the D block short note first. The last part. When you're writing the anion complex of complex anion, you can see here number 2. Number 2 complex and negatively charged complex. Complex anion. Complex anion, when you write the name, you have to be very careful about the name of the metal. So the name ends in 8, the metal cuprate, right? Ferrate. Right? We don't write iron 3, copper 3 like that. If the complex is positively charged only, it's chromium 3. The previous one, positively charged complex, we just write the name of the metal with the oxidation number. But if the complex is anionic or negatively charged complex, then the metal, the name ends in cuprate, ferrate. That list also I have given here. Here can you see all the possible ones I have given here, right? Aluminate, and actually aluminium is not D block, but you can get sometimes complexes with aluminium, but it doesn't form colored complexes. Cobaltate, ferrate, manganate, vanadate, chromate, cuprate, plumbate, nickelate, platinate, zincate, cadmate, titanate, silicate, like that. So most commonly you get like actually this copper, chromium, cuprate, and then cobaltate, ferrate, manganate. So mostly you get this stuff. Nickelate you can get. Actually lead and aluminium not under D block. Lead and aluminium are not under D block. Even tin, they are under P block, but you can get complexes. That's why. Zinc also possible. The most common one you can highlight on the line. Nickel, zinc, copper, chromium, cobalt, iron, manganese. Mostly you get complexes from them, right? But the resource book you are given only very few, right? The metals. Then that's why they have given the rules, and prefix di tri for 3, tetra for 4, penta for 5, hexa for 6, right? Number of ligands, when the number of ligands increase, when we use the prefix, that is to denote the number of ligands. So here the complex anion, they have given complex cation first, so the same thing. nickel 2, tetramine copper 2, hexac chromium 3, like that. Chromium 3 is space ion, okay. Then complex anion, this is what I told, tetrachlorocuprate 2 ion, cuprate, this one we have to be very careful. Okay, look at the screen. Now this one positively charged complexes, so the complex cation, you can directly get the oxidation number by looking at the charge. If all the ligands are neutral, this charge is directly, you can get nickel 2, nickel 2. Here copper, because ammonia is neutral ligand, therefore it's just copper 2, right? Copper 2. Then is chromium is 3 plus, no, neutral ligand, therefore is chromium 3, chromium 3, right? Chromium 3. But when you write, you have to find the oxidation number correctly. The most important thing when you write the complex anion, you have to predict the oxidation number. If you get the wrong oxidation number, your name will be wrong, no marks. So here is 2 minus is not equal to this. So what happened? You have to put chlorine. Chlorine is minus 4, minus 4. To get the net charge, 2 minus, this should be plus 2. So this is easy, like that. That's how you get copper 2. Copper 2. So chlorine minus 1 into 4 minus 4. To get net charge 2 minus, copper must be plus 2. Then next one you can see cobalt. How to predict the cobalt, the oxidation number? So chlorine is minus 4. To get net charge 2 minus, this should be plus 2, like that. So therefore the oxidation number, and if it is complex anion, it's cuprate, not copper, cobaltate, not cobalt. Is that clear? So therefore you can put a star for complex anion. You have to be very careful. What are the two changes? Predicting the oxidation number based on the charge, and the name of the metal ends in 8, ends in ATE, right? Copper become cuprate, like that. They have given that in your resource book also. In your resource book also they have given, this is they have given a list here, right? Ferrate, nickelate, right? Mercurate, you have to add, I think, to your, have I given mercurate in the, no. Can you please add that to your short notebook? Mercurate I have not given, no? Hg, no. So you can write here mercurate. Mercurate I have not added. Anything anywhere? No. All this I got. 2, 3, 4, 5, 6. 6 into 6, 36. 6 into 3, 18. 18 plus 2, 20. Yeah. Please write mercurate, Hg. Here they have given only 1, 2, 3, 4, 5, 6, 7, 8, 9. Only 9. Argentate I have given manganate, argentate. Manganate, argentate, yes, no. Argentate, manganate. Yeah. Please add mercurate. Any questions? Any questions? How many of you have done this theory? Like, I mean, in your theory class, have you done this? D-block, the complexes, the nomenclature? Please raise the hand those who done theory before. I don't know. Maybe sometimes you might have forgotten this now, right? You are done, right? Okay, all of you are done, right? Good. But with time you'll forget it. My advice, after every few months, or if you can do it monthly, better. But after few months, or you have to do 1 or 2 examples. Otherwise, you'll forget it. And the other, my next one, some students, they make this tetra, like, you know, the make the, it's capital, the first letter capital. It's not necessary. All should be in simple. That also please add to your short notebook. All the letters should be in simple. All the letters should be in simple, because in like common practice English, you write the first letter capital, should be simple. That also you can write to your short notebook. All the letters should be in simple, including the first letter. And yeah. And there's one more thing. So when you take, okay, this is number 1, number 2, number 1 I explained, number 2. Let's see number 3. Complexes is simple cation, cation simple. Now is a neutral one. Overall is the compound is neutral. If it is neutral, not necessary to write the word ion. You have to write after the oxidation number, you write this word if there's a charge. If it is neutral, no need to write this word ion at the end. So here number 3 I have not put ion. So because they are neutral, I mean the minus charge get cancelled by the simple cation. So complex anion and simple cation. Now imagine you get simple complex anion ends in 2 minus. Then what happened? To cancel this 2 minus, you need K2 here. K2. Then we don't call it dipotassium, right? Remember, it's understood by looking at the charge of the anion. You can decide how many potassium required. Then you don't need to use dipotassium, tripotassium is not necessary. That also very important. That also bit important. I don't know whether they have given an example similar one in the resource book, but I think it's yeah, it's given. Can you see in this is the resource book one? Here they have not used dipotassium, right? Okay, so you should be able to separate. Now this is the hardest one. Now the number 3 and 4 is more complex. Mostly in the exam you get that type. Let me explain this one now. Now here cation is simple. This one cation is simple. I'll come to the first that one. Simple cation and complex anion. Wait, I'll use white background. Because no point of just doing the questions without refreshing your theory knowledge. Because last few weeks I did continuously organic, so I thought of like for a change at least do like little bit of inorganic chemistry also, because anyway we couldn't do much revision from this part, that's why. And anyway there's a anyway you are getting this in the exam definitely, right? Yeah. Okay, so let's see this one. Here the cation is simple, right? Cation is simple. Simple cation. And anion is complex. Cation is simple. And anion is complex. Now you have to separate them back to the, now first you have to decide the charge of the anionic complex. So this, to get Na2, it should be what? COCl4 2 minus. COCl4 2 minus. Right? 2 minus. So to cancel this 2 minus, you need 2 Na2. 2 Na plus. So we can decide this by looking at the charge. By looking at the charge, you can decide whether it's 2 or 3 or 4 or 5. So therefore, it's not necessary to write disodium. So that is one of the common mistake I have seen. So they write here mostly even in the term place, some students write disodium. Like that's only for the ligands. Simple cation we don't put ditri. That's very important. That if you write disodium, then 0 marks in the exam. So since anion is complex, and the other most important thing, always when both cation and anion is available, number 1 you have to write the name of the cation. Whether it's complex or simple, cation first and then anion second. When you are writing the name, cation first, second anion. Cation first, then anion. So if that has, whether it's complex cation or simple cation, anyway the cation should be written first. Very important. Please write it. Whether cation is simple or complex, when writing the name, cation should be written first and then the anion. Very important. And when writing the cation, simple cation, we don't write ditri. If you write, then no marks in the exam. And the other thing is, this is complex anion. So complex anion, this one become cobaltate. That is also a bit important. If this was possible complex, then you can write just cobaltate. Plus the oxidation number also you have to write here about how that is predicting the oxidation number. Important. To get 2 minus what? Cobalt should be what? Plus 2. Plus 2 and minus 4, then you get the net charge 2 minus. Plus 2 and minus 4, you get net charge 2 minus. So therefore it should be what? Cobaltate 2, right? Cobaltate 2 within bracket. And then we don't write the other important thing, you don't write tetrachloro. It should be tetrachloride. Tetrachloride. They have given here tetrachloro. I think that's a mistake. It should be there's a big mistake in the resource book. So they have given here tetrachloro. It should be chloride. Please make that correction in the resource book. It should be tetrachloride, not chloro. Right. And the other thing is between cation and anion there must be a space. You have to leave a space between cation first, anion second, and between the cation and the anion there must be a space. So example here, sodium is space, tetrachloride, it should be chloride, not chloro. They have this is like a big chlorococo. What is this called? Chlorocobaltate. Okay, chlorocobaltate. Okay, no space in chlorocobaltate. That's not a problem. And any questions? So these are the important points here. Right? When you are given both cation and anion, whether it's simple or complex, the cation name first and then the anion. Between the cation and the anion, there must be a space. And predicting the oxidation number of the D block metal in the anion complex important. And where all the negatively charged ligands, the name ends in O, chlorido. You omit the last letter of the anion name and add O. And that also bit important. And all the letters should be in simple, no capital letters here. And between the oxidation number the name, no space, right? Here no some is not deliver space here no space. So I am now highlighting the common mistakes we have observed. Okay, common mistakes that we have observed even like past experience when marking. Now any questions? Do you have any questions? Is that clear? Some of you asked little bit of theory, but now okay, so there's one more I have to explain. Okay, cation simple and anion complex. Shall I erase this? That's what they have given, no, in the resource book. Complex anion and then cation simple and anion complex. That's it. Okay, anyway, they haven't given anything else beyond that, but anyway, I'll use the D block short notebook for the rest. Resource book, after that they have directly gone for the coordination number. After simple cation and complex. There's one more thing. This also there. Sorry. And this also I didn't explain this one. Right. This also I'll explain this one. Complex. Okay. First I explained simple cation, complex, and now this one is what? Anion is simple. Now here anion is without this anion. What happened? Without this anion, this complex become what charge? 2 plus. You can decide the charge of the cation complex cation. You can decide the charge by looking at the anion. To get Cl2, that should be 2 minus 2 plus. 2 plus. To get here Cl2, that should be 2 plus. Sorry. Now anion simple here. Well, you can write just anion is simple. I mean simple anion. Now the cation is complex. So cation complex. Here the cation is complex. Now I told you earlier whether it's simple cation or complex cation, but always any name, the cation, the name should be written first. So I'll give one more example. Do we ever write so NaCl? Do we write ClNa? No, we call it sodium chloride. We will never call it chloride sodium. It's sodium chloride, not chloride sodium. Sometimes you can't, because cation should come first. That's very important when writing the name, as well as when you are, mostly what happened here, you are given X and Y or X and A and B or something like that, then some students mix up. So if A is cation, A should be written first, then AB2 like that, or AB like that. So if A is cation, A should be written first. When you get the real symbol, you will do that, but when you are given X, Y, Z or P, Q, R, S, some other symbols for the instead of real symbol, then they change the order. So complex cation, the name should be written first. What is this? Hexamine. Hexamine. Hexam is 6. Amine means ammonia. Now do we need to write here nickelate? Just nickel, huh? Remember, not nickelate. NiCKL, nickel. Why it's nickel? Because cation, complex cation is positively charged. Complex cation is positively charged. Therefore, if complex cation is negatively charged only, it's become nickelate. So first, all the ligands should be written at the beginning of the name with the correct alphabetical order without considering the prefix. Ditry without considering the prefix, the alphabetical order without considering the prefix. Only the name is considered, name of the ligand. And the chloride. So do we need this also the one common mistake we have seen? Some students, they write here dichloride. Now they write here hexamine hexamine nickel 2. Some student write here dichloride. Don't do it, because we don't need to, without do we need dichloride to predict the whether it's 2 chlorine or 3 chlorine? No, we can decide that by looking at the charge of the complex. Now here hex, okay, look, imagine, forget about the formula. Let's build the formula by looking at this name. Hexamine means what? 6 ammonia. Hexamine means 6 ammonia. Then nickel means N9. Nickel is N9. Now what is 2? 2 means what? Nickel is 2 plus. Nickel 2 means 2 plus, because ammonia is a neutral ligand. This 2 plus completely belong to N9 nickel. Then if it is 2 plus, we can put Cl2. So we don't use ditry. We can decide by looking at the charge of the complex cation. Is that clear? Therefore, it's not necessary to write here dichloride. After writing hexamine nickel 2, don't write dichloride. That is wrong. Just chloride. Just chloride. If that was, now here chlorine is not a ligand. Chlorine is not a ligand. Ligand in the sense, like, it's not directly linked with the linked to the central metal ion. Central metal ion is nickel, so it's not directly linked. Ni2 plus is not forming a coordinate covalent bond with Cl. That's the reason. That is to neutralize the charge of the complex Cl2. So is that clear? So therefore hexamine nickel 2, not nickel 8, and it's nickel 2 because complex is positively charged. Plus, when you write the simple anion, you have to leave a space. Here you have to leave a space. That's also very important. Some students in a hurry, they forget it. These are the common mistakes, right, when you are doing when you are answering this. So there must be a space here. That space is important. Plus, the name ends in this name of the simple anion. Don't write here chloro or chlorido. Dichlorido, don't do it. Space chloride. Don't write dichloro or dichlorido. That's wrong. If that was a ligand directly linked to the central metal ion, then you can make it chlorido, dichlorido, trichloride can. But here chlorine is not a direct ligand attached to the central ion, metal ion. Any questions? Is that clear? Any questions? Now what are the 3 things I told now? I told 4 things. Now what? Simple, what is this? Simple cation complex. Right? Complex cation, complex anion, complex cation I told first. Then I told complex anion. Complex anion. Then next one, complex simple cation and complex anion. Simple cation, complex. I'll give that as a summary. You can copy down. The out one of this you will get for the exam. Definitely they will not. They cannot ask anything out of that. I'll write the list here. Look at the screen. Nomenclature of D block complexes. So this is how you should do it. Sorry about that. Nomenclature of D block complexes. Right. Which lesson are you all doing now in school? D block organic. This is summary. D block complexes. IUPAC nomenclature of D block complexes. So copy down this summary, everyone. Please copy down this summary. IUPAC nomenclature of D block complexes. There are 4 types. What? Number 1, complex cation. Complex cation. Second, complex anion. Complex anion. Number 3, complex simple cation plus simple cation and complex anion. Complex anion. The next one, please copy down. These are the different types of questions you can get. Complex cation, number 1, number 2, complex anion. That also, now all 3 I explained. Simple cation, complex anion. Next one is number 4. Number 4 will be complex cation and simple anion. Okay. Last one will be what? Number 5. Both are complexes. Cation also complex, anion also complex. Mostly in the exam they will give that type. Right? This complex cation and complex anion, that is easy. No? Mostly they will give this last one in the exam. Mostly they can give this also. The last 3, 4, 5 they can ask mostly in the exam. Complex cation plus complex anion. Complex anion. Both are complexes. Is that clear? If you want to write an example and each from my D block short notebook also, you can get an example for this. These are the 4 types you can get in the exam. If you want to write one example on each, so I'll write one example on each. So the complex cation, you can write what? Hexamine chromium, right? NH3 6. You can just one example on each. NH3 hexamine chromium 3 plus, Cr 3 plus. Now this complex cation. So complex anion, you can write what? Tetrachloro cuprate 2 minus. Tetrachloro cuprate 2 minus. That is complex anion. So not, it's cuprate. Why cuprate? Because anion is negative charge complex. Negative charge complex. Then simple cation and complex anion. Simple cation and complex anion. They have given one, even in the resource book also they have given, right? Resource book also they have given a similar one. Simple, say sodium like this, Fe F6Na3, like that. I'll put like this. You have done, I think this is very popular one. I'll give that one. Hexacyanoferrate 2. K4 FeCN6. How to write this? So this is simple cation and complex anion. Hexacyanoferrate K4 hexacyanoferrate. Here how to decide now? Oxidation number of iron here. Here minus 6 ni, minus 6 here, right? Cn is cyanide, Cn minus cyanide. So minus 6 Cn. Then to get here plus 4. outside you should get plus 4. To get plus 4, what should be here? That's how you can decide. That should be minus 2 or minus 3. Iron, anyway, there are only 2, right? Iron can be ferrous or ferric, Fe2 plus or Fe3 plus. So iron not having any other variable oxidation state other than 2 plus and 3 plus. So then it definitely should be plus 2 or plus 3. So then to get plus 4, this should be plus what? Minus 6 plus what is plus 4. So you should get here iron will be what? Iron will be plus 2, right? Plus 2, plus 2. So that's how you predict the oxidation number of the metal D block, central metal ion. Central metal ion is iron. Iron is 2 plus here. So this is called hexacyanoferrate. Hexacyano, not iron. Actually, this is negatively charged. If you separate this back, if you separate them back, you will get like this: FeCN6, right? FeCN6. What minus? 4 minus. FeCN6 4 minus here. 4 minus. If you separate them back here, then you get what? To cancel this 4 minus, you should get 4 potassium ion, like that. So it is hexacyano, not iron 2. Oxidation number of this one is, what is the oxidation number of iron here? Plus 2. Then you get net charge 4 minus. Minus 6 and plus 2 will be minus 4. So cancel minus 4, you need 4 potassium. So therefore hexacyano, since it is a negatively charged complex, so it's become ferrate. Since it is a negatively charged complex, the name of the metal ion ferrate. So remember this, not tetrapotassium. Don't ever write tetrapotassium. So even in common nowadays, like, so kind of commonly you have heard about this Prussian blue precipitate test for chemical test for iron, hexacyanoferrate. Potassium ferricyanide, that is a common name actually. Potassium ferricyanide, K3FeCN6, potassium ferrocyanide. What is this called? If you only write, then commonly you call it potassium ferrocyanide. Potassium, we don't write tetrapotassium. Potassium ferrocyanide. That is a commercial name, common name. But IUPAC is what? IUPAC is hexacyanoferrate. I told you this IUPAC thing, what comes. If you can search those things also in the leisurely, you can check those things, because Sri Lanka is very famous for searching in web, but so mostly they are famous for searching the wrong thing, right? But actually if you are searching the correct stuff for you academically, you can, very important for your improvement in your study. So I told you, did I tell you this IUPAC one periodic table? You can search in the IUPAC, then you will get all the guidelines and how that happens, and naming of this even element from the periodic table itself you can learn. Did I tell that about that website IUPAC? Okay, right. So you can then so that is number. So that example I elaborated more. Then next one, what is complex? What is the next one? Complex cation and simple. Complex cation and simple anion. Complex cation and simple anion. I'll give one example under each, then it's easy to understand. Otherwise, if I just give like complex cation and simple anion, you should know, you don't know. But even remember all this, I put the cation first. Cation first. Cation come first. Cation come first. If both cation and anion they are, whether it's simple or complex, cation, the name should be written first. Always. Then cation is complex and anion is simple. Cation is complex and anion is simple. Complexes with complex cation, simple anion. I'll give one example for that. So you can take I'll give like this complex cation. I'll give this one, Fe OH twice FeOH twice, H2O4, H2O4. Now I want to write the simple anion Br, right? Br simple anion. How many Br should I write? Now the cation I have already written here. The cation I have done here. Now what is the charge of this cation? Who can tell me? What is the charge of this cation? I put here 2OH. 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 Who can tell me the charge of this cation before I then I can decide how many anions should I include here. Yes. Vinhara gave +2, Ishara gave -2. Now actually it's I have already given here number 4 is complex cation. Complex cation means what? The cation should end in positive. No? This should be positive. I'm asking whether it's +2 or +3 or +4 or what. There are two things I need. This one I need overall charge of the complex cation and oxidation number of ion. Two things I am asking. What the net charge of the complex cation and charge of the oxidation number of ion. Yes, who can tell me? Overall charge is +2 or +3 or minus or what? Forget about the oxidation number of ion. First tell me the charge of this complex. What are the ligands here? Two ligands, hydroxide and aqua. So tetraaqua is neutral. Tetraaqua is neutral. Then what is the negatively charged ligand? Dihydroxido. What is that? Dihydroxido. Dihydroxide. Right. Some of you, okay, I think overall charge actually it's -2. It's -2. Can I put this one is neutral and this one is 0. So the 0 charge, what is neutral? What is neutral ligand? Therefore you can't. Then can I put here iron? What is the oxidation number of iron now? How to decide this charge? Oxidation number of iron. But there are two possibilities. No, what are the two possibilities? +2 and -3. Either iron should be either +2 or iron should be either -3. Now how to decide? Sorry, +3. Sorry about not -3, +3. Iron only two variable oxidation numbers. +2 or +3. Ferrous or ferric. Now I'm asking which one is best match? What is the best match here? Assign in +2 or if you put +2, what happens? This becomes 0, no? This is not a neutral one. This complex is cation. I have given here the heading cation, complex cation and simple anion. Now definitely you should get a plus charge you should get here. So now we have decided whether it's +1 or +2 or +3. So then what is the second option? Iron. So iron +2 does not, +2 won't match. +2 won't match. Then only possibility is what? +3. When only +3 is there, you get a positively charged complex. If you put here +2, then you will not get a positive complex. Do you understand what I'm saying? If you put here +2 and -2 get cancelled, then it's become a neutral complex, neutral complex. So therefore overall charge is plus. Very good. Okay, do you get it now? This most important part is this. Not to memorize the name. So here to get my, okay, what again, what OH is -2, OH -1 into -2 definitely. So this one, how to decide? Either +2 or +3. How did we omit +3 here, +2 here? If you write +2, this become a neutral one. So this is not possible. Therefore +2 I'll erase. Then only possibility is +3. Then only you get overall charge plus. Then how many anions should I, to balance this, what is the anion? How many anions should I include here? I can use Cl or Br or whatever. Br. If I want, I can put a Br. To cancel, then I will erase this plus charge. Do you understand now? So I'll write here the oxidation number of iron +3, no? +3. So this type of question they can ask in the exam. This type of question definitely they can ask in the exam. So here it should be plus 2 is not possible. If you write plus 2, this becomes 0. Do you understand? Now you have write here plus 3 definitely. Plus 3. Then only you get plus 1 here. To cancel that you can put BR. Okay. If you write BR, don't write plus charge at the end. If you write BR, no need to write here plus. Because plus get cancelled by BR. So what is now? Complex cation is complex. Complex cation. And anion is simple. Anion is simple. Simple anion. Simple anion. And complex cation. Cation is complex, anion is simple. Is that clear? Any questions up to here? Any questions up to here? Then let's see the hardest one here. This is the hardest one. Both are complexes. Number 5. Both complex. So then also I'll give one example for this kind of one. I have given a lot of examples in the short notebook also for this. When both become complex. Anion also complex. Cation also complex. Let's see. I'll write this kind of one. Copper tetramine. Please copy down this summary in a short notebook. Copper tetramine. And then I'll write the anion with a different color. Pink. FeCN6. FeCN6. Now this is the complex cation. Complex cation. This is the complex anion. Complex anion. Please copy down this. And when you are writing the name, what should be written first? Cation name should be written first. Tetramine, copper. Next one is separating them to the charge. How to predict the charge and the oxidation state. That is the hardest part. Predicting the overall net charge, overall charge of each complex, overall charge of each complex, and the oxidation number of the metal. Oxidation number of the metal. Who can tell me the oxidation number of copper here? Copper, there are two possible oxidation states, +1 and +2. Tell me, what is the most suitable oxidation number for copper here? By looking at the anion, you can decide the oxidation number of the cation or charge of the cation complex. Charge of the complex cation. In other words, charge of the complex cation will be equal to the oxidation number of copper, because ammonia is neutral ligand in tetramine. Yes, who can tell me the, only one of you gave the answer. +2. Pramodi gave +2. Okay. What about the others? Is that +2 copper? Or +1? Or any other oxide? Or 0? Or what? There can be 0 also. Yes, Ishara also gave +2. Correct. Very good. Both Pramodi and Ishara correct. +2, no? How did you decide this? Because it's iron. Look at the negative one. -6 here, right? -6. It's a different color. Let's see. So I'll write like this. Here -6. Then what is the net charge here? +3 also possible. +2 also possible. How to decide whether it's +2 or +3? Look at here copper. What is the only possibility? +1 or +2? Either +1 or +2. If I put here +3 for iron, what problem will arise? What problem will arise if I put here +3? Iron can have +3 or +2. Then it become, what is the net charge? What is the anion then overall charge? Anion become 3 minus. 3 minus. 3 minus. Then can you have 3 oxidation number 3 plus for copper? No, not possible. I think you understand what I'm saying now. Then it's become 3 minus. So then iron should be, copper should be what? This side should be 3 plus 3. That's not possible. Copper cannot have plus 3. Copper maximum plus 2. Then what is the, how to adjust this? Minus 3 minus 3. Not possible because copper cannot form plus 3. Therefore, definitely this should be 2 minus or minus. Either 2 minus or minus. So if you put here minus, then also you are in trouble. Can I put minus here? Then you can tell here plus 1. Then iron become what? Plus 5. To get here minus 1, iron should be plus 5. That is not possible, right? Minus 1, minus 6 plus 5 will be only minus 1. So copper can get plus 1, but can iron have plus 5? Not possible. Iron cannot have plus 5. So therefore, we'll put here plus 2. That's the only possibility is plus 2. Plus 3 also not possible. If you put here plus 3, plus 2, then it's become hexacyanum. Hexacyanum ferrate 2. Oh, there's one more. Sorry. There's one more thing I had put here 2. Otherwise, it doesn't match. I had put here 2. Otherwise, there will be a big problem. Yeah, I had put 2 here. Otherwise, my complex is wrong. Okay, now you can see you get here net charge 4 minus. Then you can get 4 plus here. How to get 4 plus? Plus 4 you can't put. That's why I put here 2 twice. Is 2. Copper oxidation number plus 2, no change. Copper oxidation plus 2, but you have 2 times of that. Plus 2 into 2, then you get plus 4. Then the 4 minus get cancelled. Is that clear, everyone? So this one you have to learn it by doing it. We'll do few examples from past papers also. Iron is plus 2 and copper also plus 2. Then how to write the name now? Which complex should be written first? Positively charged complex should be written first. So then it's copper. Tetramine copper 2. Before you write the name of the anion, you have to reverse space. Tetramine copper 2 space copper 2 space hexacyanide. What is that? Hexacyanide. Ferrate, not iron, ferrate 2. I don't have space, right? I am reading tetramine copper 2 space hexacyanum ferrate 2. Why 2? Now we predicted the oxidation number of each. Metal. Copper here plus 2, here iron plus 2. So then ferrate, this become ferrate 2 because of 4 minus the overall charge. This become copper 2 because it's positively charged complex. Is that clear? That is the hardest one you can get. So I have gone according to the increase in order of the complexity. Do we need do you have any doubts or any questions or any clarification, or shall I move on to the next part or the past paper questions? Any questions? Did you all finish copying down this? Shall I erase? Anyone please raise hand, and if anyone is still copying down the summary of this, they don't ask anything out of this, the maximum possible one in A-level papers. Okay, I'll give you examples. You may post the answer to the chat before I go to the fast paper questions. Is that clear now? Who had, I think Pramodji, as I remember, Pramodji only asked to revise this. Uh, anyway, the others also you can comment. Now imagine like then I can get prepared for that. You now about few weeks back only she told me, as I remember, but anyway it was in my head. That's why I thought of revising this today. Even the others like Ishara, Tamasha, Vinhara. When you study, if you feel like this section now is going to be hard for me and I have forgotten this, then you can send to my WhatsApp. You can say, sir, I need to revise this little. Then because without studying, without doing questions, if you're not answering the questions, then you don't know whether you have forgotten this or not. You don't know whether you don't know. That is the most terrible thing. Some students, they don't know that they don't know. They don't know that they don't know. That is terrible. They get to know that in the exam only. Until that they think they know, but actually they don't know. In other words, they have forgotten this. Sometimes memorizing part. Now they have to refresh that memory again. Is that clear? What I'm saying? So therefore, you can put a small like no. Don't tell sir, I won't revise this entire lesson. That's all right. But anyway, then I feel like you have not studied this properly at all. When you're actually studying, when you're answering questions on alone only, you get problems to your head. Okay, then let's move on to the next part. Okay, Ishara asking enthalpy diagram now. Okay, right. Okay, we'll do it. Enthalpy. Not now. I'll do a small revision for that. So can we discuss how to draw enthalpy diagram? Okay, enthalpy diagram. Right. Okay, shall I erase the screen? Right. Let's move back to the paper questions now. Wait. Before I move to the questions, I'll give one or two examples to check to test whether you have got it or not. Okay, please copy down this. I will after that we'll go for the past paper questions. I'll give one example. K3. Please tell me the IUPAC name of this. K3 FEC. Please copy down these examples. Right? Example for the first example. K3 FECN5 NO. NO close bracket. Please can you post the answer to the chat, or you can unmute and tell me answer. FECN5 NO K3. Yes, what is the answer for this? You can post the answer to the chat. So this one also. FE CN twice NH3 4 plus yes. Number one, potassium. Okay, Pramodi gave the answer and in her also. Potassium pentacyanide. Okay, nitrosyl ferrate 2. What about the others? Pramodi gave ferrate 2. Ishara gave ferrate 3. What about Tamasha and Tamasha gave answer. sorry, Tamasha also gave, and Vinhara, potassium pentacyanide nitrosyl iron 3. Now see the three different answers. I got now three different answers for the first one. Potassium pentacyanide nitrosyl 1. Tamasha gave iron 2, right? Pramodi gave ferrate 2. Then Ishara gave ferrate 3, right? Now Vinhara gave potassium pentacyanide nitrosyl ferrate 2. Vinhara gave the same answer given by Pramodi. Both Pramodi and Vinhara gave the same answer, potassium pentacyanide nitrosyl ferrate 2. What is the correct? Okay, let's see. Remember, no part marks. If you do a simple mistake, then no marks in the exam. Look at the screen. Okay, potassium space. Potassium space. Potassium space. After that, what should come first? Alphabetical order. Cyanide come first. Cyanide. After that, you can't write just cyanide. Pentacyanide. Pentacyanide. Potassium space pentacyanide. Pentacyanide. After that, nitrosyl. Why nitrosyl? Is a neutral ligand. NO is neutral ligand. I think that's the problem. Some of you have put a charge for that. This is a neutral ligand, very important. Neutral ligand. NO. So this is -5. Now here to get here +3 this side. To get +3 this side, what should be the iron? The value for iron. Iron should be then, to get +3, iron should be +2. Can you understand that? Iron should be +2. Then +2 and -5 become -3 or net charge. Is that clear? Here you get -3. And -3 and +3 is get cancelled. Okay, and non-neutral. So then what? Pentacyanide nitrosyl, iron 2O, ferrate 2O, what? Ferrate 2O, iron 2. Because it's a negatively charged complex, overall charge will be 3 minus. Overall charge will be 3 minus. Then it's become definitely ferrate, not iron. Who put iron? Tamasha, not iron. Ferrate. Ferrate. Then what? Ferrate 2O, ferrate 3 now. Ferrate. Look at the oxidation number, +2, right? Oxidation number is +2. Then you get ferrate 2. Ferrate 2 here, 2, ferrate 2. Ferrate 2. Ferrate 2. Okay, done. Simple mistakes. Tetracyanide. Pentacyanide. Right. Then let's see the other one. Can you quickly post the answer for the next one? And here I don't write ferrate 2 iron. Ferrate 2 iron, no need, because ion no need, right? Because it's neutralized by potassium. Is that clear, the mistake that you have done now? Tamasha put previous one. Potassium pentacyanide nitrosyl iron 2. Iron 2 can't, Tamasha. The simple mistake, it should be ferrate, Tamasha. Then Pramodi, potassium pentacyanide nitrosyl ferrate 2. Pramodi, your answer is correct. Very good. Vinhara also, your answer is correct. Tamasha, the problem, potassium pentacyanide nitrosyl iron 2. No, iron is the problem. Right. Then, so don't we use ferrate when the, yeah, that's why I use ferrate here. Yeah. Yeah, that's why we use ferret. Tamasha said, don't we use ferret when the complex? Yes, that's why I wrote ferret here. No problem.
Okay, sir. I forgot.
Okay. Then Pramodi put the answer for the next one. Good. What about the others? What about the others? I'm waiting for the others also. Pramodi, Tamasha, Nishara, Vinhara. What is the answer for the next one? Number two. Number two. What should come first? Alphabetical order. Tetramine. Tetramine cyanide. Dicyanide. Tetramine dicyanide. Oh, dicyanide tetramine. Alphabetical order, right? Yeah, what should come? Tetramine. Very good. Tetramine. Tetramine. Just cyanide only. It should be Pramodi. Tetramine. You have put cyanide or it should be dicyanide, Pramodi. That is a simple mistake you had done. Okay. Then don't be in a hurry. Be careful with before you post the answer. Tamasha tetramine dicyanide ferrate 3. Dicyanide ferrate 3. Very good. Ferrate 3. Tamasha, what is the mistake that you have done? There's a simple mistake, Tamasha. What is the mistake? Can you identify that? Very on. Okay, good. Iron is missing now. Very good. Tamasha, the rest is correct. So you have to put after ferrate 3, leave a space and write ION9. Now you have understood this. Ishara tetramine dicyanide ferrous. Oh, no. You can't write ferrous. Ferrate. Right. And can you write ferrate? No. You can write ferrate also. Why? Because it's a positively charged complex. We had write ion, not ION ion. IRON ion. Is that clear? Now from Tamasha, the second mistake, you have put ferrate. Why did you put ferrate? Because the overall charge is plus ne. Tamasha, two mistakes. One is what? Not put in the ion at the end, and second mistake, write in the ferrate word. Don't write ferrate because it's the positively charge. Only for negatively charged complex you write ferrate. Two mistakes. Actually, not to find your mistake, I am telling this. Next time, I hope you will not do that. That's why, right? That's why I am commenting on each one's answer. Now, Ishara, tetramine dicyanide, problem is ferrous. Oxidation number wrong, and we have put ferrous, that is the problem. Why? Okay, I think you have just look at ferrous one. You thought this plus, overall charge plus, therefore ferrous plus. No. Ferrous, you have to put the whatever the number that you put within bracket, that is the oxidation number, not the overall charge. I am commenting on the Ishara's answer. Ishara, the oxidation number you have to put here within bracket, not the overall charge of the complex. Oxidation number is not. Can iron have plus? Never. Right? Ishara, iron only plus 2 or plus 3, not plus 1, never. So it should be, and the other problem ferrous, so it should be ferrate, not ferrate, iron. Tamasha Isara, I told Vinhara. Tetramine dicyanide iron 3. Tetramine dicyanide iron 3 space iron. Very good. Very good. Who is this? Vinhara. Vinhara, your answer is correct. Very good. Tetramine dicyanide iron 3 space iron. Very good. Okay, now it's not that easy. So simple mistake, then it will become your MCQ. Also very important. Structure is okay. Okay, I'll write the name. What is the name now? Alphabetical order. Tetramine. I'll write the name now. Tetramine. Alphabetical order A and C. Tetraamine dicyanide, and don't write capital letters. Tetraamine dicyanide, iron, iron 3. Why 3? To get over, look at here charge. Some of you are not really, so this is -2 ne? To get overall charge. I'll write below this, otherwise you get confused with the previous one. This is -2. Therefore, to get overall charge plus, iron should be +3. Can you understand that? Iron is +3. That's why iron 3 here, right? Iron 3 space iron. And the other one, iron also, be careful. Iron IRON iron, the other iron ION iron. That also, some students, they mix up this in the exam. Iron is, iron 3, IRON iron 3. And the after space iron is ION iron. Okay. Only Vinhara gave the correct answer for that. Then next one. I'll give one more. Because I need the upper. Shall I erase this? Anyone still copy now? Please raise the hand. Done, right? I'll erase both this. I'll give one more. Let's see how many of you will get this. Okay, please tell me the answer for this one now. This complex. K2 Fe K2 Fe CN6. How to write this? Can you post the answer to chat? Now the complex is what? Which one is complex? Anion or cation? The complex has become anion or cation? Anion has become simple or complex? Anion is complex, no? Cations are simple. Yes. Okay, this one. Now Fe CN6 ne? Let's split this into Fe CN6. What are the two possibilities here? If you get here 2 minus, can you have 2 minus here? Because here itself to +2. And this one either +2 or +3. +2 or +3, these are the two possibilities. One of that we have to select. If you get plus 3, then it's become what? You should get here what minus? Anion. 5 minus. Is that possible? Can you have plus 1 here? Not possible, right? Therefore, definitely you can omit plus 3 from here. If you get here plus 2, let's see plus 2 to get then plus 2 plus 2 plus 4. Then you can have here 4 minus. That will that match? If you put here 4 minus, here 4 minus, here plus 4. Then what is the possible oxidation state for this ion? You get 4 minus here, plus 2, here minus 6, plus 2 and minus 6 you get minus 4, and minus 4 and here plus 4. Then what is the oxidation number for this one? Plus 2. So both these become plus 2. Is that clear? Do I need to explain again? Can you respond? Some of you have already posted the answer. Vinhara and Tamasha and Pramudeep. Potassium ion 2 or ion 3? Ion 2, right? Tamasha, you can't write ion, only ion, because ion can have plus 2 and plus 3. That's right. D block ones, you have to mention that. Oxidation number you have to mention. If there's a variable oxidation state, you have to mention that. Someday you might ask, don't we write potassium 1 here? No, we don't need. Why? Potassium only plus 1 always. That's why we don't write potassium 1. And potassium and iron, no space. That's also very important. So I'll write the name now. I'll write it. Potassium. After that, without leaving a space, iron. Iron what? 2. Iron 2. Then leave a space. That is the cation part. Cation, now there are two things. There are two metals, potassium and iron. So after that you leave a space here. After leaving a space, you have to write hexacyanide. Yes. Hexacyanide ferrate. Hexacyanide ferrate. Why ferrate? Because of this 4 minus negative complex, ferrate. Otherwise I can write here iron. Ferrate, what is the oxidation number? Don't write ferrate 4 minus. Ferrate 2, right? Ferrate 2. Do I need to write iron here? No need. No need to write iron. Why? Because it's neutralized by potassium and iron at the beginning. Potassium. Okay, good. Did you get now? Pramodi, you have put potassium ion 2, hexacyanoferrate 2. Very good. Small mistake, Pramodi. Between potassium and iron, no space. Between potassium and iron, no space. Because both these considered as cation part. And we write them together. Hexacyanoferrate 2. Very good. Now, potassium ion, hexacyanoferrate 2. You have predicted done almost done. Potassium ion to hexacyanoferrate 2. Okay, Ishara correct, right? Good. Okay, so that's kind of a hard one I gave. So therefore, you should have some understanding about the possible oxidation state of D block metals, right? So iron can have only plus 2 and plus 3. Do you understand now? Remember, all the D block metals can have plus 2. All the D block metals can have plus 2 oxidation state. Except the scandium, that's very rarely. I have given at the beginning of your D block. Shall I erase this? Anyone done? Anyone still writing? Okay, I'll erase this. Okay, let me show you this. Possible oxidation numbers. I have given that in the D block short notebook at the beginning. Except, please write that if you want. Except scandium. Except scandium, all the others can have +2 oxidation state. But +2 oxidation state seen in all the D block metals except scandium, right? And that is very important. And the other most important, sometimes they can ask which of the following is correct or incorrect regarding D block metals. Highest oxidation state shown by manganese. Highest oxidation number is by manganese, and lowest oxidation number by copper. That is, copper can have lowest. So if you can mark these things in your, even in a short notebook, lowest value. Now in combined state, second highest you get vanadium. And which one has highest variable oxidation numbers? Vanadium and manganese. Manganese has overall highest more variable oxidation state. Highest variable oxidation states. Highest variable oxidation state. Who? Manganese. Highest variable oxidation states. So those things be important, no? And you should know transition and transition thing also. And out of all this, the scandium and zinc shows only one oxidation state. Those things, be careful in the exam, they can ask. What? Zinc and scandium, no variable oxidation states. No variable oxidation states. Any questions? Any doubts? Right. Then shall I erase this? Anyone still copying down? Right. Then let's move on next. I'll erase this. Now let's discuss some of the past questions. No need to get a printout, so I'll tell the year. Let's see the recent papers. As I remember, this is 2000. Please write this is two. You can, okay, forget about don't write the answers. I want you to copy down this in your, I'll highlight this green. I want you to copy down this to your writing book, and please write please forget, don't look at the answers. Please write the name. You write the name and check whether that answer is there among these 5 answers. As I remember, this is 2012 A level. 2012 A level, question number 12. Can you please find write the name without looking at the 5 in the exam also? You can save time, because if you read all 5 answers, then it takes time, you get confused. So without looking at the answers, you write the correct name and see whether that answer is there among those 5 responses. Please post the answer to the chat, or else you can write the answer directly, like question number 12 answer is this one, that way also you can put it, because when you are typing this, you can do the mistakes. First you write the name and then see whether that answer is there, that the correct answer you can post to the chat. Done? Separate them back to the cation and anion complexes. What is the most common oxidation state of chromium? +3, right? Chromium in most of the complexes, chromium +3. Chromium +3. +2 and +6 also there, but most common one is +3. Okay, let's see your answers now. Most of you put the fourth answer. Tamasha fourth, Vinhara third, Pramudi third, Ishara. Two of you fourth, two of you third. Why third and why fourth? Let's see. Examine chromium 3, hexacyano. Those who have put the third answer, what is the mistake here? Any mistake in the third answer? Can you tell me? Huh? What is the mistake in the third one? Look at the screen. What is the mistake in the third?
The space?
Yes, correct. There must be a space. See, tricky one. Both third and fourth correct. But in the third one, there's no space. Good. So now you can understand the mistake Vinhara and Pramudi. Right? Okay. Now you have changed the Vinhara, changed the answer to fourth. Good. But the problem is in the exam, this can happen. Same thing happen in the exam. At the time when you're answering this, during the exam, you do the mistake. After handing over the papers or the answer sheets, then only when you come back home after the exam, then the mistakes come to your head. You don't study before you go home, before you discuss with anyone else. Sometimes some of the stupid or the careless mistakes that you had done come to your head. So after going home after the exam, when you go home, and then after sometime in the evening, some of the other mistakes that you had done in the paper automatically come to your head. You understand? That means your brain is working during that time. So it's like kind of your RAM. Your RAM is bit slow. So it's uploaded later. Sometimes when you're going to hand over the paper, then some mistakes come to your head. Then you feel like pulling this paper back and again making the correction and doing. But you can't do that now in the exam. So sometimes you might have already come across this even in your school term test and even in the oral exam. So therefore, even 1 mark matters, counting in the A level. So that will affect you as a disco. Okay. Yeah, good that you asking now. Who is asking this question? Ishara is asking, sir, is it cyano or cyanide? Yes, Ishara, it is cyanide, but this is old syllabus. That's why I told when you answer in the past papers, new syllabus only you get the cyanide thing. So it should be, they have given here cyano, actually it should be cyanide under new syllabus. That is one difference. Therefore, all this cyano. Therefore, it should be cyanide under you. That's why I told you to write the name first. Then you will make it cyanide and then the answer is third. Answer is fourth. Answer is fourth. But it should be cyanide. Make it cyanide. Huh? Make it cyanide. Any other doubts here? Do you suggest any other answer other than this? Right. Not among these 5 answers. If you want, you can write any other way. Like if you want, you can tell. Ask. Right. The next one. Shall I erase this? This is, as I remember, this is 2013 paper. Can you put the answer to the chat? Don't look at the answers. First write your name. Your name is like your answer. Let's separate write the name of the complex, and then compare or check that answer is there among these 5. Assume that in all these answers cyano becomes cyanido. This is much easier than the previous one. What is the answer for this? Yeah, make it cyanido. Yes, yes. Assume in all these cyanido. In all these they have got cyano, no? Make it cyanido. I told you this is all syllabus, no? But anyway, we have to do the past papers at least for 30 years, no? Therefore, we'll make these changes, amendments, and do it. That's what to do. These are our past papers. A-level past papers, 2013 MCQ. If you want to write near this, 2013 A-level. 2013 A-level. I got the answer now from Ishara, Vinhara, Tamasha. Pramadi? Pramadi. No. What about Pramadi? Very good. Now most of you all got the answer, correct answer. Very good. Except Tamasha second answer, Vinhara gave second answer, Ishara gave the second answer. Okay, Pramadi also gave. Okay, very good. Answer is second, no? Very good. Okay, now you got it. This is much easier. Why? You can see the charge. Therefore, it should be cobalt, not cobaltate, and it's a positive charge complex. And alphabetical order, what should come first? Amine, then cyanido. Right? Cobalt, you can easily predict the oxidation number. How? This is -2. Then cobalt should be +3. No, cobalt should be +3. Right? +3. Cyanido -2. Cyano. Cobalt should +2. Okay, I'll erase this. Question number 12 answer is second. Then question next one again. The same MCQ that 12, 12, 12 like in these papers. So this is 2016 A-level. Can you try this one? Now they have given the name. You have to predict the complex. Name is given. You have to draw it. I mean, you have to write it. Can you guess the answer? Yes? What is the answer? This one. Okay. Vinhara gave the answer. Ishara gave the answer. What about the others? Pramodi. Pramodi, not Pramodi. Okay, Pramodi also gave. So all of you get the same answer, third answer. Very good. Excellent. That is much easier, no? Like I think you feel more comfortable writing the name. I mean, writing the formula from the name, no? So that's correct. All are correct. Answer is 3. Answer is 3. So I don't need to waste time on that. Ne? Wait, answer is 3. 3-diamine, bromo, carbonyl hydrido. Right. Now this is the problem here. Now, yeah, now all of you gave the third answer. Tamash is asking, sir, can you explain what is wrong in the others? Yes. Now this is also you have to remember. Remember that the ligands are listed in the alphabetical order, uh, and if you take, so there are four ligands. There are four ligands. What are the four ligands mentioned here? Amine, bromide, and carbonyl and hydride. So always remember, complex ion should be inside the square bracket. That is number one. Complex ion should be always. Can you write this in your short notebook, everyone? Right, when writing the complex ion should be inside the square bracket. Square complex ion. Right. That is one thing. That is anyway that agrees here. Then the other one, in the complex ion, the metal cation should be integrated at the leftmost corner. Again, I am telling it should be integrated in the leftmost corner, and then the ligands. That also agrees here. Are you all writing this? Number one, complex ion always should be within the square bracket. Number two, the complex ion should be the metal, right? Metal cation is here cobalt. That should be at the leftmost corner and followed by the ligands. So actually they have considered here alphabetical order of the elements in each ligand. Alphabetical order. Diamine bromide, right? Diamine bromide. Then you get carbonyl. Then you get hydride. Diamine bromide. Yeah, the alphabetical order of the ligands they have considered here in the name. When writing also they have given the same order. So what is considered here? The alphabetical order of the elements in each ligand bonded to the metal ion. Alphabetical order. bromine, A, B, C, D, E, F, G, H, I, J, K, L, M, N. Okay, that, I mean, do you understand what I'm doing now? Alphabetical order means this one, not the name. A, B, C, D, like that one. A, B, C, D, E, F, G, H, I, J, K, L, M, N. Now let's see. What come bromo? Bromo should come after cobalt. After cobalt, before bromo, bromine comes. After that C comes, carbonyl comes. A, B, C, D. When you're writing the name, you have to follow, take that order, alphabetical name. Here the element they have considered. C, cobalt, maybe bromine, B, right? Then after that, A, B, C, D, E, F, G, H. H, hydrogen H is here. Then after that, N, amine, nitrogen. The ligand has the element nitrogen. Element N comes here. N, ammonia. So is that clear, everyone? That's what they have considered actually. B, C, H, N. No, but these are the four ligands. These are the four ligands. When writing, you follow the alphabetical order of the name. Here, alphabetical order of the symbol of the element here considered when writing the structure. Actually, the answer should be third, all of you, but actually the marking scheme answer is fourth according to this. So it's nicely mentioning. With this bromine number 1, then C, cobalt, ABC, D, E, F, G, H. This is 3 hydrogen, and fourth is N, nitrogen. B, C, H, and N, nitrogen. So that is actually by considering the alphabetical order of the symbol, I mean, of the element in the ligand. But anyway, in the resource book, like anyway, just keeping this in your head. So in that case, so you have to consider, otherwise all these same, no problem. Any questions? The correct answer is not 3 then, no? In that sense, answer is 5th, not 5th one, no? How can you put hydrogen then H ne here? Hydrogen is H ne? So H cannot, before H you have bromine B, carbonyl C. Is that clear? Who asked that question? Okay. Tamasha, you asked, sir, can you explain what is wrong in the others? I explained, right? From this, is the 5th answer? Then no, not 5th, 4th one. Is that clear, Pramodi? Tamasha?
Yes, sir.
Right. Okay, so this is 2016 one. Then I have posted you this is recent paper, and then 1999 onwards. Right. I am not going to now next day I'll discuss these ones, the other D block MCQs. I'll discuss the IUPAC ones in the past papers. 2010, 8, 7, 5, 2, 2002, 2001 also there's a one. I will start with this. Question number 2 is 29th MCQ. The other paper I have posted you 2 papers, D block MCQs 1999 to 2011, nearly 12 years. 12 years, and with this earlier we discussed 2012, 13 and 16, altogether 15 years papers, right? 15 years papers MCQs. 15 years D block complexes the names I have given. So then you can definitely do the next upcoming one also. Please tell me the answer for the 28th MCQ now. 28th MCQ 1999. 1999. 28th MCQ, what is the answer? Make it cyanide because all syllabus they use cyanide. Now cyanide become E, you have to cancel and put here you have to omit E and you have to make it cyanido. Omit E and add O. 1999, before your syllabus, like they have a 50, 60 MCQs. Now you get only 50, one MCQ, 1 mark for each MCQ. Before that, all syllabus they have a 60 MCQs. That means less than 1 mark. But now if you get one MCQ wrong, you are losing 1 mark. For them now they are losing less than 1 mark because they get 50 marks for 60 MCQs, 60. Question of 59. No? Yeah, I'm waiting the answers from you. Okay, I got the answers from everyone. Yeah, Pramodi and Tamasha gave 5th answer. None of the above. Vinhara gave 3rd, Ishara gave 3rd. 3 and 5. Let's see. 3 and 5. IUPAC name of compound is potassium space hexacyanide. Let's see, cyanide. Ferrate 4. Yeah, it's nicely matching. Ferrate 4. Ferrate 4. If it is ferrate 4, you can't get K4. I will write the name. I'll write the name. Look at the screen. This is okay. I'll split this. This should be what? Fe Cn6 4 minus ne. 4 minus ne. Then only you can put K4 ne. Then only you can put K4. If you put this one the charge 4 minus only, you can put here K4. Is that clear, everyone? By looking at K4, I put here 4 minus. To get 4 minus, what is the oxidation number of iron? Iron oxidation number will be what? This is minus 6 and this is minus 2. Minus 2. Can it be ferrate 4? Can it be ferrate 4? Okay. Who put the answer here? Okay, no problem, no worries. I'm discussing 28th one. From Ishara? 20. Okay. Some of you have put the 29th one. Sorry, I'm in 28th. Sorry about that. I encircled this. Can you see the screen? I encircled the 29th one. 28th one. Sorry, 28th. 28th, Pramodi correct, Tamasha correct. Okay, it's all right. Then 29th, you have put the 3rd answer. I'll check that one. Is that clear, everyone? None of the above the answer, right? Because it should be ferrate 2. This plus 2. Then only you get 4 minus. So it should be ferrate 2, no? Ferrate 2 is not there in any of this. Overall charge minus, ne? Therefore ferrate 2. Ferrate 2 is not there, no? In any of this. Okay. Done? Alright, okay, good. You have understood it. Now 29th, let's see now 29th. 29th, Vinhara and Ishara, no? Yeah, Vinhara and Ishara no need 29th because you have already posted. But Pramodi and Tamasha only need to post the answer for the 29th. Okay, Pramodi gave the answer. Very good. Vinhara also gave the answer. Very good. Tamasha? Yeah, very good. Answer is 3. All of you are correct. Very good. Excellent. Answer is 3. Right. Okay. Correct. Very well done. Pramodi also correct. Tamasha also correct. Vinhara and Nishara also correct. Let's move to the next one. Question number 30. 30th MCQ. 30th MCQ. Yes, what is the answer? You can see the screen clearly now. Can you post the answer? First check the IUPAC name and then you can decide second and the fourth answer which is correct or not. We'll split. Now the best thing is you can separate this into the complex. Cation and anion. So this is 2Cl minus. Then this should be what? 2 plus, right? Definitely it should be 2 plus. Pentamine. Pentamine. Square bracket. This is 2 plus, no? 2 plus. 2 plus. Pentamine cobalt 2. Pentamine cobalt 2. Okay, wait. Pentamine cobalt 2 space chloride. Cobalt 2 space chloride. Is that there? Pentamine. Chloro also there. Sorry, I didn't see that. Chloro also there. No, sorry about that. Pentamine chlorido cobalt. We assume that all this chlorido, they don't. This will make it chlorido because it was pentamine chlorido cobalt 2. Cobalt 2 or then cobalt 3. It should be cobalt 3, no? Then cobalt 2 become cobalt 3 then. Because it should be plus 3. To get here 2 plus, it should be minus 1. This should be plus 3. Then only you get 2 plus. Then only you get here 2 plus. Minus 1 chlorine. Ammonia is neutral. Cobalt, then you get here cobalt 3. Cobalt 3. Is that clear? Cobalt 3 space chloride. Cobalt pentamine chlorido. You get chlorido. Pentamine chloride cobalt 3. Dichloride can't. Dichloride can't. Because of di it's wrong, no? Because of di it's wrong. Dichloride we don't put. Here because it's wrong because of 2. It should be 3. So both the IUPAC names wrong here. Then let's see the others. Number 1, 3 and then the others 2. Okay, IUPAC name it doesn't match with 2 and 4th answer. What is the correct answer? Okay, let's see. Question number 30. Vinhara gave second answer. Pramati gave third. Ishara gave fourth. Tamasha gave third. Answer is 3. Answer is 3. Second one is wrong. You can understand now, Vinhara, right? Because of the oxidation number can't be 2. Oxidation number is 3, right? Okay, Ishara also gave third now. The answer is 3. Is that clear? Vinhara? Answer is not second. Second one is wrong. Second one is wrong because it can't be cobalt 2. It should be cobalt 3. Okay. Vinhara? Right. So it has coordinate covalent bond. Yes, covalent bond and ionic bond because of Cl oppositely charged ions. They are a complex cation. Complex is cation, cationic complex, and simple anion then is plus and minus, Cl minus, and this overall charge plus. So that is ionic bond. And between the metal ion and the ligand, so the coordinate covalent bond. Within ammonia, if you take NH3, there are 3 NH bonds, that is covalent bonds. So it has all 3 types. Coordinate covalent bond is there between the ligand and the metal ion. Then it has covalent bonds, example NH3 has 3 covalent bonds, and ionic bonds because of the cation and anion, there are 2 complexes. So this is charged, this is ionic bond. Ionic bond. Is that clear, everyone? Let's move on to the next one, 31. Any questions on that? Can you understand, right? It does not give a precipitate, that is wrong, no, silonitride, so it can give. It does not give a precipitate with aqueous Ag because Ag can go with Cl minus. Ag can go with Cl minus forming what? AgCl. AgCl. Okay. Then next one. 31. Can you give me the answer? 31st. 31st. 2020, 2005. 31st one. First you write the compound, the structure. Ammonium space. Cation first, anion second. Aqua penta. Aqua is H2O. Pentafluoro means make it fluorido. Consider that as fluorido. Pentafluorido. 5 fluorine. Ferrate means negatively charged complex. Complex is anion. Anionic complex. Anionic complex and simple cation. Yes. Right. Vinhara gave the answer and Tamasha gave the answer. Ishara also gave answer. Pramudi gave answer. Vinhara, Tamasha and Ishara all 3 gave the same answer. Answer is 3. But Pramudi gave 5th answer. Why 5th and why 3? Answer is 3rd. Answer is 3rd. Pentafluoro. Aqua. Pramudi, 5th on the ammonium is NH4 plus. It is not a ligand because ammonium is space. Pramudi. Ammonium space. Ammonium space, and then I'll highlight with 2 different colors. This is aqua. Now let's see. All these are correct. Pramudi, I'll explain your answer. So the ammonia means NH4 plus, right? And then this one you get this part, aqua pentafluoro, that means ferrate, Fe, aqua H2O, and 5 fluoro, F5. This ferrate 3. Ferrate 3 means what? Oxidation number of ferrate 3 means oxidation number of iron is 3 plus 3. That's why ferrate 3. So then the overall charge is what? What is the net charge? This is minus 5. Minus 5. Minus 5 and plus 3 is 2 minus. 2 plus. Sorry, 2 minus. 2 minus. 2 minus. Then is matched. 2 minus. To cancel 2 minus, you should put here NH4 should be 2 times. NH4 should be 2 times. Understood? So it should be 2 times. Say 2 minus. Okay, what is the step? First you get the oxidation number of the iron. Then you get to go for this one. Then you go for this one. That is the order. I put 1, 2, 3 the order. First you predict the oxidation number of iron, and then you go for the net charge of the anionic complex, and based on the anionic complex charge you decide how many ammonium ions. So when you combine you get the formula NH4 twice, because there must be 2 ammonium ion. Good, to cancel that 2 minus charge, NH4 twice. Why? Because of to cancel 2 minus overall charge. Okay, is that clear, Pramodi? Right? Done? Either one. What is the answer? 3, right? Correct answer is third, right? Correct answer is 3. Okay. Others are correct. Then let's move to the next one. 32 answers. So 2007 A level, question number 34. Yes. Quickly post the answer to the chat. If you answer all this, then you will be fully okay with this one, IUPAC nomenclature of inorganic compounds. Yes. Vinhara, okay, correct, very good. Vinhara, correct. Ishara, correct. Tamasha, correct. Pramodi, correct. Very good, excellent. Answer is 4th. Do I need to explain? It's easy, right? Potassium, space, pentacyano. It should be cyanide. When you write the new syllabus, it should be cyanide. Bromo, why bromo? Because alphabetical order, right? Alphabetical order, then cyano. And ferrate 3. No need to write here iron, just here space. Okay. Then I'll erase this. Question number 33. What is the answer? 2008. Quickly tell me, it's not hard, very easy. Everyone, now you should be able to give the correct answer. Don't do careless mistakes. Now you know the technique. You know the technique now. 33. Yeah, okay, Tamasha, very good, correct. Vinhara, correct. Ishara, correct. Pramodi, you gave the third answer. 33. 33. Penta aqua hydroxido. Ferrous? Why Pramodi ferrous? I told you we don't write the word ferrous, no? So we write iron, right? We never use ferrous ferric here. Either ferrate if it is anionic complex ferrate, or else if it is cation, complex, so it's just iron. So this is wrong, Pramodi. Because of ferrous, it's wrong. Is that clear, Pramodi? It's not a hard one. Because of ferrous is wrong. It should be iron. And the oxidation number, what is, okay, look at the other mistake, Pramodi. To get 2 plus, what should be the oxidation number of iron? OH is minus, OH minus. H2O is neutral. To get overall charge 2 plus, what should be the oxidation number of iron here? Plus 3, no? Plus 3 and minus 1, you get the net charge 2 plus. Is that clear? I'm telling the Pramodi. Understood, Pramodi? Can you see the screen? Question number 33. Third one you can't take because of ferrous, plus the oxidation number also wrong. Oxidation number is 3 plus 3 need to get overall 2 plus. OH is minus 1, then iron should be plus 3. Then only plus 3 and minus 1, the overall charge 2 plus. Okay, right. So the answer is others are correct. Others are correct. I think maybe you had done a careless mistake. You know the technique, right, the Pramodi? Right. Answer is 5. Answer is 5. Very good, the others. Right. Then question number 34 also tell me the answer. 34. I'll erase the screen. 34th MCQ. 34. 2010. 2010 A level. Chemical formula of pentamine hydrox. Make it hydroxido. Here hydroxo, but actually at a new syllabus we are making this hydroxido. Pentamine iron cobalt 3 oxidation number. Be careful. It's not cobaltate, cobalt. That means positively charged complex. Cation is positively charged. Complex cation and simple anion. Nitrate is NO3 minus. All these NO3 minus. Di or trinitrate or whether it's NO3 2O, NO3 1O, NO3 depends on the charge of the cationic complex. Decide the cationic complex, the charge. Pentamine NH3 5 ne, right? Then hydroxide OH ne. After that cobalt 3. Cobalt 3 means again what? Cobalt is COH. To get here 3 plus. Sorry, not that one. Cobalt 3 means oxidation number of cobalt is 3. Oxidation number of cobalt is 3 here. That is the meaning of cobalt 3. I'll highlight here. Cobalt 3 means oxidation number of cobalt is 3. Oxidation number of cobalt is 3. Right. And here minus 1. Minus 1. What is the net charge now? What is the net charge? Net charge will be 2 plus. To cancel 2 plus, how many nitrate required? 2 nitrate required. To cancel 2 plus, 2 nitrate required. Nitrate required. Very good. 34. Vinhara gave 5th answer. Others, all the others gave the 3rd answer. What is the difference between 3rd answer and 5th answer? How many nitrate required? Vinhara. How many nitrate required Vinhara to cancel this 2 minus? Sorry, 2 plus. To cancel 2 plus, you need only 2 nitrate. I highlighted that black. Is that clear? To cancel here 2 plus from the cationic complex overall charge 2 plus, to cancel that you don't need 3 nitrate. Only 2 nitrate ions enough. Okay, Vinhara, right. Okay, good. Others are correct. Answer is 3. Okay. Not 5th one. Right, I erase this. Not hard. Be careful when you are writing the answers. Then 35. 35. Are there anything else? Yeah, 35. So we'll do this one and stop. 35th MCQ. 35th MCQ. What is the answer? That is 2011 A level. 35th. What is the answer? Yes. Can you post the answer, Richard? So now today I did 15 years papers, right? 15 years papers. Inorganic, IUPAC and I mean the D block complexes, and I explained the theory and short note also given. So then you anytime you can refer the short note book also. Okay, I'm waiting the responses from everyone. At least the last one. Can everyone give the correct answer? I am expecting the correct answer from everyone, at least with this last one. 35. Be observe carefully. Don't be in a hurry. Do it. Take time and do it. Don't do careless mistake. Even if you lose marks because of your careless mistakes. Now already two of you have given the answer. The same answer or both of. Yes. Very good. Very good. All of you are correct. Very good. Answer is fourth. All of you are correct. Excellent. So now do you have the confidence? Do you need more questions, more revision? Can you manage now? Very good. All of you are correct. Answer is fourth. Very good. Well done. Right. Or do you need more revision? Are you all okay now with this, IUPAC nomenclature of inorganic compounds under D block? And try to do the remaining MCQs of this paper. This D block, the other questions also try to do before the next Tuesday night. Right. Pramodi, are you okay now? I think Pramodi asked about this that IUPAC thing. I think about few weeks back. That's why I thought of discussing them. Even the others, if you have a problem with any other section previous lessons, tell me. I'll discuss more questions from those lessons. Try to do the remaining MCQs of this one. Right. Next day I'll discuss them. B block. Right. Then shall we stop for today? Tamashan, this month you need I think because of you, I think we put the class Tuesday night. No problem. We'll continue next week also Tuesday night this time. And try to do. I'll post one more now. Next week I will be discussing organic also. And try, if possible, try to do the remaining questions of this one, the D block one. Yeah, the questions from D block. Right. Okay, then we'll stop for today. Good night, everyone, and God bless you all, and stay safe.
Thank you, sir. Good night.